Alrighty, we're back at looking at Lewis dot structures, but this time for a polyatomic ion. So the first thing that you'll notice with a polyatomic ion, so this is nitrate from the back of your periodic table, and all polyatomic ions have a charge to them. And we learned last unit that a -1 charge means that this whole molecule gained 1 electron. So let's go through the steps to calculate how many bonds this molecule will have so we can begin our Lewis dot structure drawings. So for nitrogen and oxygen, I like making my chart of how many electrons the elements want compared to how many they currently have. And then take a look at the total. So nitrogen and oxygen, they are not one of the 3 exceptions to the octet rule, so they both will want 8. Now oxygen, there's 3 of them according to the little subscript, so I'm going to take 8 and multiply it by 3 for a total of 24 for all the oxygen atoms in this molecule. Nitrogen, when we look on the periodic table, nitrogen is in group 5, so it's going to want 5 valence electrons, and each oxygen atom has 6 valence electrons. So we have 5, and then we have 6, and again I'm going to multiply by 3 for a total of 18. So when I add these up, I'm going to get 32 total for how many electrons this entire molecule wants, and then I'm going to have a total of 23 electrons. When you see an odd number like 23, that should tell you something, because eventually we have to divide the difference here by 2, and if I have an odd number, well, that's going to give us some sort of decimal. So that should also set off like a red flag, like, oh, something else needs to happen here. So when you take a look at this -1 electron, that means I gained 1 electron. So the whole molecule actually has an extra 1. So this number, I'm going to add 1 to show that's coming from the extra electron that it gained as an ion. So really, I have 24 total electrons that we have. When I take the difference of 32 minus 24, I get 8 electrons shared. So this is a nice little even number. I can divide by 2 to calculate the number of bonds that will exist in the entire molecule. This is going to give me 4 bonds. When I look back at the chemical formula, nitrogen comes first. It's not an exception, so it's going to go in the middle of the molecule. Then I'm just going to take 3 oxygens, sprinkle them around. It doesn't matter as long as they're all around nitrogen. I have to draw at least 1 bond, so 2 dots, for each oxygen connecting to nitrogen. So I just drew 3 out of my 4 bonds. So I have 1 more to go. So does it matter where I put my 4th bond? Well, the answer is no. I could put it here in between my oxygen and nitrogen on the left side, or I can put it here in between the oxygen and right below nitrogen, or I could put it on the right-hand side. When you have choices where it doesn't matter where that last bond goes, and we call this resonance. And we will put an R next to the drawing to signify that. All right, so then the very last step is I gotta look at all of my atoms and make sure that they fulfill their octet rule. I have no exceptions here, so that means I need 8 dots around each atom. So my oxygen on the left already has 2 shared with nitrogen, so I fill in with 6. Same thing with the oxygen down below. The oxygen to the right, though, is sharing 4, so I only need 4 dots to draw in. Last but not least, because it has a charge, I need to take some brackets, put it around the whole thing, and put a -1 charge to show that there was an electron that was gained to the entire molecule. And that's it, drawing Lewis dot structures for a polyatomic ion and also what it means to have resonance in a drawing.